All right. Hi. Last 10 years of React performance is what my talk is kind of going to be about. So, all right, who here has ever used React 18? Nice. What about 17? 16? 0.14? I think that was my first one. 0.13? Wow, all right. 0.3? I do not believe you. Well, so React has been around for 10 years. Over these 10 years, it went through a lot of APIs. Some of them improved compatibility, some of them directly aimed to improve performance. But today, I want to talk about the improvements that most of the developers didn't notice, that I didn't notice for years, improvements that React flipped under our noses to make our apps faster. In other words, I want to talk about the invisible hand of React. And to start, let's talk about useEffect. Who here uses useEffect? Who loves useEffect? One person. Wow. All right. Well, I don't love useEffect. Most people I've talked to don't love useEffect, but I'm going to show you one reason why useEffect is actually a pretty good hook. So useEffect is a hook that lets us synchronize things, right? We can run some logic when some props change, when some state change, or on every change. Before useEffect was introduced, the same thing was achievable with lifecycle methods. You would have a class component, a component that's written as a class, not as a function, and that class would have a render method that returns the JSX, and methods like componentDidMount or componentDidUpdate that would allow me to synchronize to prop changes just like useEffect, but with more lines of code. So when React 16.8 came out, useEffect pretty much replaced componentDidMount because it was just so much easier to use. And that was a good change, but alongside that big, nice development experience change came a much more hidden but very intentional performance change, which eliminated a whole class of performance issues, and which I would like to talk with you about. And to talk about it, I have a quiz. So I have this React component. This React component renders a button, and also during rendering, it sets document body background color to red. Also, when this component mounts, it sets the document body background color to blue. So my question to you is, which colors will the browser render? Option A, red then blue. Option B, blue then red. Option C, only blue. And option D, only red. Who thinks it's A? Who thinks it's B? Good. Who thinks it's C? Who thinks it's D? All right. Well, the right answer here is C, only blue. Now, I have this code. This is the same component, but written to use useEffect. Which colors will the browser render here? Who thinks it's A? Who thinks it's B? C? D? E? No. All right, yeah, the right answer here is indeed A. So with componentDidMount, the right answer is only blue, but with the useEffect, the right answer is red, then blue. This difference is a result of very intentional performance decision that drove useEffect designed and helped React to fix a whole class of performance issues. But to understand this difference and to understand the issues it fixed, we need to take a detour into how browsers render things under the hood. So browser rendering pipeline is complex. But I'll be talking about this stuff who has already seen this before. All right, good. Yeah, good. There's not too many heads. So browser's rendering pipeline is complex, but we need to know only two things about it. So first, whenever the browser reacts to something, maybe a timer, maybe an event listener, maybe whatever, it always goes through 4 stages. First, it runs the JavaScript. Then, if the JS has updated the page, the browser recalculates the styles and recalculates the layout. And then, once that's done, the browser paints the results on the screen. That's the first fact, always 4 stages. The fact two is that browsers use a lot of caching. Every time the layout updates, the browsers cache it and remember it until it needs to update the next time. So for example, if you render the app for the first time and the browser calculates that the height of the header is 200 pixels, the browser will remember that and keep that in memory for as long as needed until you say click the header and the header expands and becomes 500 pixels in height. So that's the second fact. So when you have, for example, a button ref in React and some JavaScript code tries to read the height of the button, the browser would not compute the height right as you access it. The browser wouldn't need to go and compute the height when you read client height. The browser would just go and read it straight from the cache. Now, my question to you is, what happens if the button which height you're trying to read is not yet in the cache? What happens if you inserted this button straight in the same block of JavaScript and the styles and the layout were not recalculated? How would the browser how would the browser know its height? Yeah. Yes, exactly. The answer is the browser will be forced to recalculate the styles and the layout ahead of time the moment you try reading them. So the moment you read the height, the browser will freeze the JavaScript, compute the styles, compute the layout, take that height, and then return the height back to JavaScript. This is a performance issue that's called a forced layout recalculation, and this was a pretty common problem with componentDidMount. Say you have a component that looks like this. It's a button component, it renders a button, and then it checks that if a button is taller than 300 pixels, it does something. And it uses componentDidMount. With componentDidMount in React, componentDidMount would run right after render within the same block of JavaScript. So if componentDidMount needs to read from the layout, like here, and if the layout isn't cached, which is pretty common because render does what? Render updates the DOM, which throws away some of the layout caching. If the layout isn't cached, and if componentDidMount reads from the layout, then what would happen? The browser will have to do a forced layout recalculation, which will freeze componentDidMount until it completes. This is a common issue, and this is a common enough issue that you can see it even in DevTools. The DevTools, if you ever do a performance recording, if you try to look into what's happening in DevTools, you might often see this layout rectangle with a text that says forced reflow is a likely performance bottleneck. And what this means is that whenever you see this rectangle, the forced layout recalculation has happened. Some JavaScript read something from the layout that is not cached, and it is slow. So compare this to the component that uses useEffect. Like with componentDidMount, useEffect runs not in the same frame, not in the same chunk of JavaScript, but in the beginning of the next frame. And this changes everything. Now, if I render the button first, React would render it, update the DOM, give the control back to the browser would recalculate the styles, recalculate the layout, paint the updates on the screen, and then only once all this is over, useEffect would run and would try to read from the layout. And so now when useEffect reads from the layout is already cached, right? It's been computed here. Cache is present, so no forced recalcs happen. No performance issues shown in DevTools. You'd only see JavaScript, style, layout, paint, and then a bit more JavaScript when the useEffect executes. Now, notice how none of the reasons why useEffect was introduced were about performance. When React 16.8 came out, useEffect, the reason to move to useEffect was that it was giving us a better development experience. I was able to put all the code in a single place. It was easier to do cleanup effects, etc. But when we moved to this new API, this whole class of issues also disappeared. This is one of the examples of React's invisible hand of performance. This is how React made our apps faster without us even realizing that. And, well, that's the first example. The second example, batching. And I have another quiz. So here's a button that has an on-click. And the onClick calls a function that says that's called make document public, and this function has 4 set state calls. First, it sets this loading to true. Second, it flips the isPublic flag to the opposite. Then it makes 2 API calls. Then it sets setPublished at its to whatever result the API has returned, and it sets isLoading back to false. 4 set state calls. The question: how many renders will this onClick cause? Sorry? Option A, 3. Option B, 4 indirect 17, 3 indirect 18. Options C, 3 indirect 17, 2 indirect 18. And option D, 4 indirect 17, 2 indirect 18. 4 set state calls, how many renders? Who thinks it's A? Really? Who thinks it's B? Who thinks it's C? Who thinks it's D? All right. Nice. Thank you. The answer is C. So this is happening thanks to update batching, which is one of the earliest invisible React performance optimization. And I suppose those of you folks who raised a hand for D did this because you heard that React 18 came out with like better batching, optimization called better batching. But better batching, or like batching, was present in React even before React 18. In fact, batching was one of the earliest React performance optimizations introduced all the way in 0.4 in 2013. It changed a bit over 10 years. It did receive a big overhaul in React 18. And, well, it's another invisible hand that makes our apps faster. Let's talk a bit about how batching works. So batching is when you have several set state calls, but they result in a single render. React 18 has 2 renders because set state calls 1 plus 2 are batched and set state calls 3 plus 4 are batched. But in React 17, only set state calls 1 and 2 are batched. Does anyone know why 3 and 4 aren't? It's not a question to you, Andrew. Does anybody else know why set states 3 and 4 aren't batched in React 17? Any ideas? Any guesses? Yeah, exactly. It's a asynchronous call. But to understand why exactly the asynchronous calls prevent React from batching the updates, let's see how React conceptually implements batching under the hood. So let's say I was Meta, and I was implementing React from scratch. What would be the simplest way I can implement a set state call? The simplest way would probably be something like this. Whenever someone calls set state, I take that state and I perform the update right away. And from my understanding, that was more or less what React did in the very first versions. Now, React 0.4 introduced batching. The subsequent versions improved it a bit, fixing some edge cases. And so in the recent versions of React, up until React 18, set state actually started looking a little more convoluted. Here's how. So first, now, in this more convoluted, more batched version of set state, whenever you'd call set state, React wouldn't process the update right away. Instead, it would take the update, and it would push the update into a queue. Second, after queuing the update, React would check if it's batching the updates right now, and if it's not batching the updates, then it would process the update queue right away, which at this point would include only one update. But if React is batching the update, then set state would do nothing. The set state would just return the control back to where it was called from. Batch updates, by the way, is just a simple global flag that various parts of React can set to true or false. And now, if you're batching, if batch updates is true and set state isn't processing the update, then something else needs to process the update, right? Something else needs to call process update queue. What would that part be? That part would typically be the function that set the flag to true. And in most of the cases, that's going to be the event listener function. Here's how this works. So when you set some event listener on some DOM node, like for example, you have a button with onClick, right? And then click actually fires, under the hood in React, the following happens. First, React flips the batch updates flag to true. Second, React fires the callback, fires your set state listener. If the callback makes any, if that callback, sorry, not the state listener, calls my event listener. If that callback, if that on-click listener makes any set state calls, these set state calls push the updates to the queue and do nothing else because batch updates is set to true, right? Then the callback completes and batch updates switches back to false. And finally, as the last step, every event listener calls process update queue to process any updates that are currently in the update queue that set state has pushed there while batching was enabled. This is how batching works in React 17, React 16, React 15. And that's why when you have this code in React 17, only the first two set state calls are batched. Because when you run on click, the batch updates flag switches to true, but the moment you await on something, your original callback, this callback, it completes. And the control returns to React, and React flips the flag back to false. And so no batching is happening anymore. Now, how does React 18 avoid this issue? How does React 18 batch the updates that happen after async if there's nothing to flip the flag, if there's nothing that can set the flag to true? The trick is that there's no flag anymore. There's this is like that, I know, Asian, East Asian religious. There's no spoon. I know, sorry, I'm improvising. So with the React 18, the logic looks different. First, the global batched updates flag is no more because all the updates are always batched without any difference. Second, the event listener, now that there's no flag, simply calls the callback directly. Third, the process update queue function is still called, but it is now called in a very specific manner. Instead of being called from setState directly, now whenever you call setState, React executes promise, resolve, then process update queue. Andrew is just doing this from the sidelines. Thank you. But what this does is this runs process update queue, but not immediately, but rather at the end of the frame after all JavaScript has finished executing. If you remember this chart from like 5 minutes ago, this is how it works. You have a frame. The frame starts running on click. That on click calls setState 3 times, and setState, every setState pushes the update into the queue and schedules process update queue. It's actually only the first setState that schedules the process update queue. The second and the third one actually check if something has been already scheduled and don't schedule more functions unnecessarily, but I simplified the previous slide with code. Then on click completes, and maybe there's some other JavaScript that runs, and only after that, after all JavaScript in the frame has completed, process update queue finally kicks in and processes the queue that was collected during setState calls and applies all setState updates at once. And this is how in React 18, setStates 3 and 4 are batched. You call setState 3, it pushes the update into the queue and schedules processing, but it does not process anything right away. Then you call setState 4, it also pushes the update into the queue and also does not process anything right away. And then make document public finishes executing. Maybe there's some other JavaScript that's scheduled to execute in the same frame. It also schedules executing. And then only after that, process update queue kicks in and both updates are processed together, resulting in a single render. This is update batching. And this is another invisible hand of React that makes our apps faster out of the box. My question to Andrei or anybody else, does anyone know how to enable this, enable this React 18 batching behavior in earlier versions of React? Unstable batch updates. Yeah, so something you could do in earlier versions of React, which I didn't put into the slides because I thought they would be too long, but I'm right on time. So let's talk about that. Something that you could do in earlier versions of React is you could import I do not, sorry, I'm next display. Does this work? Yes, this works. You could import unstable batched updates from React DOM. It does not work. It's a scary name. It's intentionally scary. The fact it's like one of the most stable React APIs. It's been around since like 0.14 at least, and then even before that as an add-on that you could have used. So it's even present in React 18, even though it's not doing anything. But if you're still, anybody still using React 17? 16? Sorry. If anybody's still using older React versions, then what you could do is you could use that to optimize to batch your updates. So this is updated batching. Let's talk about one more thing, which is Suspense, and guess what? I've got another quiz. So here I have a bit of JS6. This is a header component with a few children. There's an icon, there's a menu that's collected by default, there's a button that opens the menu when you click it. Now, imagine this is a server-rendered app. If it's a server-rendered app, there will be a few moments when the app won't work as expected. For example, if the app is just loading and the JavaScript has not yet loaded, then the button wouldn't do anything, right? You would click it and there's no JavaScript and nothing happens. But if the JavaScript has been loaded, but the app is still being hydrated, well, this is my question to you. What happens if the button is clicked during hydration, not before hydration, not after hydration, but during hydration? Option A, nothing. The click is ignored. Option B, nothing. A warning is logged. Option C, the click is remembered and is replayed once hydration completes. And option D, the page freezes. And who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? The answer is D. The answer is D, because the whole page would freeze. The whole page would actually be already frozen at that point. Hydration by default freezes the page for as long as it takes to hydrate the whole app. If your app has 10,000 components, then the page would be frozen for as long as it takes for React to render the whole 10,000 components. All right, another quiz. This is the same app, the same question. By this time, the insides of the header are wrapped with Suspense. The question is, what would happen to the page now? A, nothing, the click is ignored. B, nothing, a warning is logged. C, the click is remembered and is replayed once hydration completes. And D, the page freezes. Who thinks it's A now? I like the commitment. Who thinks it's B now? Who thinks it's C now? Who thinks it's still D? The answer is still D. The answer is the page will freeze again, but this time it will freeze for a much shorter period of time, only to hydrate the elements inside Suspense, only the icon, the menu, and the button. Here's how this works. So Suspense, generally, is a component that's used for data fetching, right? The idea is that you wrap some parts of your page with Suspense, and then when you're fetching something, Suspense would render you a fallback, which is the loading icon. However, that is only one part of the idea behind Suspense. A much less noticeable part of the idea is that Suspense also enables something called selective hydration. The idea is described in a discussion in a React 18 working group, which is like 5,000 words. So I'm not going to read all that to you. And I go in depth into it in my talk. But the gist is basically as follows. As your site or app grows, more and more parts of it are going to get wrapped with Suspense. Like, for example, if you're Airbnb, maybe you'll have this search wrapped with Suspense, and each listing wrapped with Suspense, and some other page sections wrapped with Suspense. And so what React does without Suspense is when the page hydrates, React freezes the whole page. React starts executing hydration, and React hydrates the Airbnb logo, hydrates the header, hydrates the avatar, hydrates the search, hydrates the listings, etc. And the whole page stays frozen until every element on the page is hydrated. If you click something in the process, well, the browser would not be able to handle that because the page is frozen. You'll have to wait until the hydration is complete. But with Suspense, React behavior changes. React will still hydrate all elements outside of suspenses in the same way as it was hydrating the page before. So it would freeze the page, and it would hydrate the logo, it would hydrate the header, it would hydrate the avatar, it would hydrate the filter. If I click the page during this time, the page will be frozen already. The React would be busy hydrating the parts of the page that are outside of Suspense. But now, everything inside suspenses is going to be hydrated in a different way. React would take the first suspense, React would hydrate the suspense without blocking the page. It would hydrate a few components, give the control back to the browser, hydrate a few more components, give the control back to the browser, and so on until the whole suspense hydrates. Then it would switch to the next suspense and hydrate it in the same manner. And then the next suspense, and the next suspense, and the next suspense, and so on. And so what happens now, if I click some suspense or something inside the suspense that is not hydrated yet, what React would do is it would freeze that, it would intentionally freeze that suspense boundary, but only that suspense boundary, wait until the boundary is hydrated synchronously, and once it's hydrated, it would take that click and it would send that to the right event listener inside that suspense boundary. So if I have this button here, for example, and I'm trying to click it and this suspense boundary isn't hydrated yet, React would select this suspense. It would prioritize this suspense hydration. It would hydrate this suspense ASAP, and then it would send that event that it's still holding to the right button. This is called selective hydration, because React selects the suspense that you're clicking to hydrate as soon as possible. And yeah, I'm not going to get into how that works under the hood because that's a whole separate talk. But this is yet another example of React shipping invisible performance improvements under our noses without anyone noticing. React's invisible hand that makes our apps faster. So useEffect, BedChain, Suspense, those are my favorite examples of invisible performance optimizations. There are quite a few more that I wanted to talk about, some successful, some not, but sadly we're out of time. So thank you. I'm on Twitter/X. Feel free to follow me, no pressure. Thanks.
Thank you. Big round of applause. So I think these buttons were also written with React, and I pushed them during hydration, so the whole light froze. So questions for Ivan?
Unfortunately, I'm not a performance consultant anymore, otherwise I would help you.
Yeah. Oh, I don't work here anymore, so. Oh. So questions, come on. Okay, Anton.
Me too.
I'm also looking for pizza.
What's going on with React 19 regarding performance and all that stuff?
Yeah, so I think I'm mostly looking forward to React compiler. Which is finally, well, I don't know. I'm not sure how effective it's going to be. We're going to see. There's also React server components graduating to stable. But, well, that's a whole separate subject that I'm not super familiar with yet. We'll see how it goes.
Hey, hi. Do you know how
Yes,
React? Do you know how React knows which component take the click handler? I mean,
yeah. So it doesn't. It actually doesn't. Like when you click a suspense, React doesn't know what exactly you're clicking at, because there are no, this is not hydrated yet. No event listeners are connected to the actual DOM nodes yet. So what React does is React freezes the page to the on-click event listener gets called on the suspense boundary. React freezes the page. React urgently hydrates the suspense boundary, React then checks if there are any elements inside the suspense boundary that could receive this onClick event that is still holding, and then only if there are, it dispatches the onClick event to the corresponding element. The drawback is that, well, if nothing inside has onClick, React still doesn't know this, so React is still going to freeze the page if you click this, even if like nothing inside is interactive. But freezing is going to be much shorter because it's a single suspense boundary. Does this answer the question?
I mean, what happens if I click on the image, but actually also the title has an onClick?
Oh, so if I click on the, yeah, so the question is, what happens if you click the image, but the title also has an onClick handler? Right, so, sorry, I'm trying to think if I can show this clearly, but okay, so this is a standard JavaScript event, right? When you click an image, the browser knows that you click an image. The target is the image tag. The thing is, React still doesn't know if the image has a JavaScript that has an onClick on it. So React holds, freezes the page, hydrates the whole thing, it checks the event target, which is still the image, checks if that target has an onClick on it, and if yes, it calls the onClick with the event that is still holding. This answer is it still not clear?
Oh yeah, I think it's clear, but we can talk later.
All right, yeah. Yeah. Any other questions? Yeah.
Yeah, sorry. Thank you for the talk. It was great. Yeah, I had a question regarding actually the unstable batch updates. Could you give us an example when things can go wrong? Because like, for example, on that example, it looked like actually a good idea to use unstable batch updates. And I've seen myself, sometimes I was forced to use it to make the app, work better.
I have literally seen no cases when something could go wrong, and I know this is very rare for an API that's prefixed unstable. But generally, this is something that I would put pretty much everywhere. I have several subsequent updates, and they're not inside the event listener. Or just upgrade to React 18, which does this for you. Any other questions?
Last one.
Oh no.
Hi. What is best practice to separate to different suspense components? Like, I can wrap every component to suspense to increase speed of iteration, or I can just make it to logic blocks or something like this.
So I actually asked Dan Baron about this on Twitter/X, and he was like, well, I mean, yeah, you could totally wrap every component with suspense. The drawback is that, like, if any component suspense, it's just going to disappear because there's no fallback on the suspense. So I'm not sure if like what I'm saying is clear, but like suspense does several things at a time, and that makes it amazing/terrible. But like if anything inside here, like if you just wrap every part of the page with suspense, and then something here suspense because you have a component that's like lazy loading, the whole thing is going to disappear. You don't want that. So wrapping everything with suspense is probably not the best idea. What I'm generally doing or saying to do is pick some logical sections like here and wrap each logical sections. The smaller the better, but probably not too small. Does this answer the question?
Okay, so as I said earlier, we're going to have a networking session after this in the kitchen. Both speakers will be there, so if you have additional questions, please, or follow on Twitter, or both. So a big round of applause for